Hello everyone, welcome back to Namalax Bengaluru Presents Current Issue of the Day episode number 189. Today we will discuss a very important development in India, that India recently built an indigenous 32-bit chip called as Vikram 3201. We'll discuss what is this Vikram 3201, what is its significance, how does it compare to other chips, and also we'll discuss about semiconductor industry in India. So this is the chip. So might be very small but very significant because of the work it can do, because of the significance it possesses for Indian space. We'll discuss why it is in use, background, 3201, significance, highlights, and way forward. Okay, so first thing is, in syllabus it comes under GS3 economy and also GS3 science and technology. The context is from powering artificial intelligence models like ChatGPT or large language models to guiding rockets into space. Chips are the brains of our digital and cosmic future. So chips are going to be very important in the current as well as in the coming future. So all the countries are running towards semiconductor, or all the countries are running towards chip manufacturing. So in this aspect, our very own indigenous chip, that is Vikram 3201 has been launched recently. So Vikram 3201 is India's first fully indigenous 32-bit microprocessor unveiled at Semicon India 2025. Designed by Vikram Sarabhai Space Center, that is VSSC, and fabricated at ISRO's Semiconductor Laboratory in Chandigarh. So it is combination of Vikram Sarabhai Space Center and ISRO Semiconductor Laboratory. You might ask, why are ISRO and Vikram Sarabhai are involved in chip manufacturing? Doesn't have to be done by semiconductor companies? Here is the twist here. Not the twist, here is a reason why they developed this chip. Because this chip is being developed specifically for space explorations. Okay, this will be used in rockets. Then, unlike chips in laptops and phones, it is tailored for rockets and satellites. It is an upgrade from Vikram 1601, which was a 16-bit used since 2009. So now from 16-bit to 32 bits. At just 32 bits, 100 megahertz, built on 180 nanometer technology, it doesn't sound powerful compared to today's superpower chips, because there are many chips which are 64 bits, which are 124 bits, which are around 528 bits as well, which are still used for supercomputers. Despite that, the chip which India has developed is very important for us. Why? Because it can survive minus 55 degrees Celsius or plus 125 degrees Celsius. That is, it can withstand cosmic radiations and power spacecraft in the vacuum of space. So the very basic idea of developing this Vikram 3201 was for us to improve our space exploration. So is the task being done here? Obviously, because it can withstand all the harsh conditions of the space as well as Earth. So it is very important for Indian space exploration as well as Indian semiconductor business. Next, why is it important? It is important because it provides strategic autonomy. That is, India no longer needs to depend on other countries for their own space exploration. Next, national security. It prevents risks of supply chain disruptions or hidden backdoors in the imported chips. The supply chain disruptions due to COVID-19 resulted or impacted India directly because China stopped its supply of chips. As a result, India was dependent on China. As a result, Indian supply chain got disrupted. So instead of depending on other countries, why not develop our own and develop strategic autonomy and also focus on national security? Next, it is a technological milestone. First time India designed and fabricated such a chip indigenously, which is a very significant development. Then performance leap, that is, supports 64-bit floating point operations, ADA programming or ADA programming language, and 1553B bus interfaces for reliable communication in space. Not necessary to understand all these things, just remember that it is capable of performing very complex tasks. Next, space grade reliability, can withstand extreme conditions as I explained, minus 55 degrees Celsius to 100 and plus 125 degrees Celsius, and radiation and vibration. Next is, what is the significance of semiconductors? Semiconductors matter because they are the foundation of modern technology. All the deep tech such as AI, the AI's large language models, and machine learning, okay, machine learning, space exploration, all these things run on the chips which are made by semiconductors. Okay, power anything from smartphones, AI servers, electric vehicles to medical devices and defense systems as well. Next is strategic importance. They are termed as digital diamonds of 21st century by Prime Minister Modi. The supply chain risk exposed. That is, the 2021 chip shortage revealed global overdependence on limited regions, prompting the countries to take or diversify and build domestic capabilities. This is what India is doing at the moment. In order to power its deep technology research and deep technology development, India decided not to depend on other countries, instead develop our own indigenous chips. Next is about global leaders in semiconductor space. Okay, so who are the actual leaders in semiconductor sector in the world? So TSMC in Taiwan, the semiconductor manufacturing company or Taiwan Semiconductor Manufacturing Company is TSMC, holds a dominant 70.2% foundry market share. That is, foundry is the labs or which are called as fabs for semiconductors. 70.2% foundry market share as of Q2 2025, commanding the production of cutting edge chips of less than 7 nanometers. The top semiconductor firms, though the Taiwan Semiconductor Manufacturing Company is the top company with respect to foundry market, the market cap is not held by TSMC. Instead, the top semiconductor firms by market cap is NVIDIA, which almost holds 3.3 trillion to 3.7 trillion. At the moment, NVIDIA is the largest market cap holding company, not just in semiconductor, but of all the companies. It is higher than Amazon, it is higher than Tesla, it is higher than Apple as well. Okay, higher than Microsoft as well. Next, TSMC, Broadcom, ASML, Samsung, AMD, Qualcomm, Applied Materials, ARMS, Texas Instruments are among the top global players. So here is the NVIDIA. Topmost is the NVIDIA, which is followed by TSMC of Taiwan, which is followed by Broadcom, which is followed by ASML of Netherlands, which is followed by Texas Instruments, followed by ARMS of UK, then Applied Materials of UK or USA, and then Qualcomm of USA, and then AMD, which surprisingly is a like daughter company of NVIDIA, because the founders of NVIDIA and AMD are brothers, the cousins. Next is Samsung, which holds around 420 billion market. So these are the important manufacturing companies in semiconductor business. What about India? Where does India stand? There are none of the Indian companies are there. So what is the stand of India at the moment? So India's semiconductor market size and the growth, that is, estimated value at the current is around 38 billion in 2023, which is expected to grow by 45 to 50 billion in 24-25, and projected to develop or double 100 to 110 billion by 2030, which is way less compared to what NVIDIA, the company alone, is developing at the moment. Next, another estimates pegs it at 53 billion in 24 and potentially 164 billion by 2033, with a compound annual growth rate of 12.5%. So we are still at the nascent stage, but there are positive signs. Next, global share. Not yet a major manufacturer, India contributes around 3% of the global electronics manufacturing value chain. Okay, electronics manufacturing chain. So this is the North India market accounted largest share in the market, and global market to grow at a CAGR of 27.72% during 24 to 2030. So 27.2% CAGR is the global growth of semiconductor industry. Okay, so Indian semiconductor market share by region is North India is the highest, East India is less, West India and South India. Okay, surprisingly South India is contributing lesser to this semiconductor market share. The global market size is in 23 it was 35.18 billion, and 2030 it is expected to reach 190 billion. And the Indian semiconductor market by application in 2023, so semiconductors most used by sectors was electronics, followed by telecommunication, information and technology, data processing, automotive, industrial machinery and other sports and fitnesses. And Indian semiconductor market by material in 2023 is for highest is tin, carbon, germanium and silicon and others. Okay, it is in billions. So this is about India semiconductor chain or India semiconductor models. So India semiconductor strategy and initiatives, though we are in nascent stages, it doesn't mean that we are not doing anything with respect to that. we are focusing on developing our semiconductor industry and chip industry as well. For that, there will be many schemes such as India Semiconductor Mission of 2021, 76,000 crore, almost 10 billion US dollar was incentivized framework for fab, display and chip design ecosystem in India. Next, production linked incentive or DLI scheme or spec scheme were targeted to provide full support for local chip design and electronics manufacturing. Next is fab projects in pipeline. That is Assam fab. Fabs are the labs for semiconductors or are called as fabs, foundry labs. Fab with a daily capacity of 48 million chips, 11 billion Tata Power chip fab in Gujarat approved, and there is also an increment in or increase in academia and industry linkage. IIT ISM Dharmad developed a low power analog chip and showcased at the Semicon India 2025. And MOUs were signed with the Keynes Semicon, 30 Tech and Sparshik to boost India's vision systems and chip ecosystem. So we are also doing collaborations with private individuals as well or private industries as well. 618 crore INR investment in silicon carbide fiber facility in Odisha by RIR Electronics. So we can see the involvement of or positive involvement of private industries is there. Semiconductor chips made in India expected in market by end of 2025 per PM's speech. And recent deals were India is also dealing with different countries and different companies. So recent deals were Micron building at ATMP plant in Gujarat. Then Tata Group entering semiconductor facts and packaging, and ISRO plus SCL focusing on space grade chips, which directly resulted in Vikram 3201. Next, design strength, that is India already hosts 20% of world's chip design engineers who are unfortunately working for Intel, Qualcomm, Nvidia, and all have big Indian teams. So if we want to build our own team, if you want to build our own ecosystem, we need to provide them better working conditions and better lifestyles in India. Then they can come back to India and work for Indian companies. Next is, okay, so challenges for India. What are the challenges India is facing? One is no commercial foundry yet. India lacks advanced semiconductor fabs in India. For example, TSMC and Samsung dominate in this one. Next is capital intensive. That is a cutting edge fab or the lab for semiconductor costs around 10 to 20 billion, meaning it is very capital intensive. Then supply chain gaps. From raw wafers to photoresistors, India depends on imports, especially from China. So we have to find an alternative for our own raw materials. Next, talent mismatch. That is very strong in design, weak in fabrication and packaging. Next is global competition. China, Taiwan, South Korea and USA are already far ahead of India in semiconductor industry. So what should be the way forward? What is required? What can India learn from companies like TSMC, Nvidia or countries like China and Taiwan? Massive fab investment, that is the fab investment should come from both private as well as government. Like Tata, Vedanta and global types should come in more. Next, R&D focus. Indigenous lithography, EDA tools and packaging should be focused more on, not just the designing. They should also be outcome of such designs. If the design is strong, it doesn't matter because after designing, the more next step is to produce them. So production or fabrication and packaging should be focused upon. Next is skilled workforce, that is upskilling engineers in semiconductor physics and manufacturing. Then focusing global partnerships with US, Taiwan, Japan, EU, trusted supply chain alliances can be made out. Then long-term policy stability, that is chip ecosystem takes at least 10 to 15 years to mature. So India should stay patient, but should focus on improving a long-term policy. This should be the way forward. Just some points for prelims. You might be discussing what is the FLOP, what is these things, is Vikram 320 in the fastest chip in the world. All these things we'll discuss. What is FLOP? That is floating operations per second. Okay, that is the FLOP. One floating point, one FLOP is one flop is considered as one calculations per second. There are various things. One is G flop, that is gigaflop, that is 1 billion calculations per second. Next is T flop or teraflop, that is 1 trillion calculations per second. Then is P flop, that is petaflop, 1 quadrillion calculations per second. Then is E flop, or exaflop, almost 1 quintillion calculations per second. So most of the semiconductors, or sorry, most of the chips around the world are at this range, but there are some various chips who are also working at p-flop ranges. We'll see some of the chips which are working at p-flop ranges, the strongest ones. So the strongest chips or the fastest chips in the world is, first one is NVIDIA Blackwell Ultra GB300. What is its capacity? It is 20 petaflops. 20 petaflops is nothing but 20 quadrillion calculations per second. Next, it also possesses 288 GB HMB3. Okay, not necessary, but just remember 280 GB can be calculated here. And then Cerebrus WSC3, which has 125 petaflops. This is normally used in supercomputers. That is why they require 125 petaflops. Then next is AMD. AMD is one of the largest chip manufacturing companies as well. It has AMD EPIC 9965 chip, which approximately has 1.8 petaflops. What is like our Vikram's calculation capacity? Okay, the Vikram's capacity is around teraflops only. Okay, it is around teraflops only. So still in earlier stages, but it is a good development. So compared to other companies, other chips, our Vikram chip is still in the nascent stage, but it is very significant for India because it caters to our own needs, that is space exploration. So it is a moment to be proud of, and so it is a moment to be rejoiced. So with this, I will end the discussion for the day. I think you learned more about Vikram and also learned about the importance of semiconductor industry and manufacturing of chips. With this, I will end the video. Jai Hind, Jai Karnataka.